The
Did you
continents
know
on
that the
Earth
continents
weren't
haven't
always where
always
they are
been in the
today.
locations that they are
They
now?
used to all be
They
connected
used to
to
be
each
in a
other in a
supercontinent
giant
called
continent
Pangea
known as
millions of years
Pangea.
ago. So today we're going to talk about how the Rocky Mountains were formed. So earthquakes typically occur at the boundaries of crustal plates, and so it makes sense to plot the locations of major earthquakes on a world map. And the Earth's crust is composed of a series of rigid crustal plates that move over the asthenosphere. And the movement of these crustal plates is the source of both volcanoes as well as earthquakes. Volcanoes usually occur at the boundary where two plates move apart, so they diverge, or at a boundary where one plate is pushed under another, so subduction. So volcanoes can sometimes occur at places not close to plate boundaries, but plotting the location of the world's active volcanoes helps us to map out the edges of crustal plates. So one Earth history theory is known as Pangaea, which there was a single supercontinent that formed in the late Paleozoic era. Some of the strongest evidence for the theory of plate tectonics emerges from the end of this Paleozoic area, where geologists think that the Earth's land masses formed a single gigantic continent. In the early 1900s, Alfred Wegener introduced the theory of continental drift. And when we look at that supercontinent called Pangaea, meaning all lands, it began to break up around 225 to 200 million years ago, fragmenting into the continents that we see today. And so this demonstrates the idea of continental drift, as those continental plates are moving, some are moving away from each other, and now some are moving towards each other. So a volcano is a spot on the Earth's surface that releases magma and heat. And like we said, they occur typically at three different zones: a subduction zone where one plate goes underneath another, so we have magma near the Earth's surface; a hot spot or a rift zone where two plates are coming apart. So the Rocky Mountains in BC and Alberta and all the way through the central United States were formed during the Jurassic period, or Mesozoic era as well. And Pangaea continued to break up and fragments continued to drift west. So the tectonic plate carrying these islands was subducted under the westward advances of the North American plate. So the tectonic plate carrying islands went underneath the North American plate. Geologists suspected that the margins of the western Alberta plate must have been a land of volcanoes and earthquakes during that time, as the one plate was going underneath the Northern American plate, because again, we'll have that magma close to the surface. Now, in the late Jurassic and Cretaceous periods, sediments created vast networks of deltas, swamps, and forests that became home to a variety of different dinosaurs. And then by the late Cretaceous period, another round of plate collisions caused another period of compression. Over this time, the effect was that the inland sea was uplifted, so that the ocean bottom came higher, the sea was drained, and any existing mountains were pushed up even higher than the main ranges. And then the front ranges and the foothills were formed. So this is why in the Rocky Mountains, we often find many aquatic fossils meters and meters and meters above sea level.